So today we discuss the Strassen method for multiplying the matrix. Now we see how we can use the matrix multiplication with the help of the Strassen's formula for obtaining the result of 2n by n matrix. We need to multiply the two matrix of size n by n. You have the n rows and n columns. B is also having n rows and n columns, so that you can multiply. And the resulting matrix we need to store in the C, and C is also having the matrix n by n. And efficiently we are going to multiply the two matrix A and B. Here efficient means we need to minimize the operations as the traditional matrix multiplication. So if you are given the two matrices of size n by n, and if you use the brute force method, then how we can multiply the matrix? What is the formula to multiply the matrix? If you have the two matrix, say for example, you are having the two matrix. Okay. So you may have some columns, you may have the rows. Okay, you have the rows. So you have the 3 by 3, for example. You may have the n by n, means any 2 by 2, 4 by 4, 10 by 10, any number. So if you want to multiply the two matrix with the help of the brute force method, and if you want to obtain the entries of the C of at this place, first row and first column, so what you need? You need to consider this row. If you want to obtain the entries for the, say for example, C and first row and first column, C11. So how you can obtain the entries for the C11? You need to consider the row first. This is the row first C. This is the matrix A and this is the matrix B, for example. So you need to consider the row, first row, and you need to consider the first column of the B. So you need to multiply this with this, and then this with this, and then this with this, and you are going to add, and then finally you are going to obtain the entries for the C11. Are you getting this thing? So row by row and column. So you have to go row and then you are going to obtain the column. If you want to obtain the entries for the C12, first row and second column, then again you have to consider this row, and you need to consider now second row columns. You have to do this. And this is the way you can multiply with the help of the brute force method. Means if you are supposed to multiply, if you want to obtain the entries Cij, then how you can write the formula for this. So you have summation A. You are going to consider the entries for the ith row Cij. So you have to, for the matrix A, you need to consider the ith row. So ith row, and here you have to use the k, because you need to vary k. Here you have the k, here k refers column, so k is equal to 1, 2, 3. So if you have the n by n matrix, n by dimension is n by n, then k will go through up to what? K is less than or equal to n and greater than or equal to 1. So k will vary from 1 to n. So you are considering the first row, first column, first row, second column, first row, third column, and first row, another column, like this. So once you are considering the ith row and kth column, then actually you need to go for the jth column of the matrix B. So when you go for the jth column of matrix B, then you need to write like this B, and you want jth column of the matrix B, and row number can vary. So this row, and then you are going to the column. Now column is fixed here I is fixed and here column is fixed, and but you are varying the row. So row can go from first, second, and up to another row. So k, you need to write k here. So whenever you write k here, then bkj. So you are obtaining the formula like this: aik and bkj. Okay. So here you are having the entries for the Cij. So you can write properly Cij. I and j. So this is the formula for obtaining the matrix using the brute force method. So once you go for the brute force method, then this is the formula you can use. If you have the 2 by 2 matrix, how you can obtain the entries? So you will have C11. Okay. How you can obtain the entry C11? Now see, this is the formula you have obtained for multiplying the two matrix of size 2 by 2. So you have the 2 by 2 matrix, you have the 2 by 2 matrix A, and here you have the B. So A is having 2 by 2 and B is also having 2 by 2. So you have, if you want to multiply, then resulting matrix C will also having the 2 by 2. So you are getting the entries like this with the help of this formula. So now the question is that what is the time you need for multiplying the two matrix of size n by n using the brute force method? Since you have your dimension is n by n, so k will go from 1 to n. So you have to consider n product here. So n multiplication you need. Okay. So number of multiplication you need for obtaining the first entry, only one entry in n by n matrix is what? N. So if you want to find the matrix multiplication of size n by n, if you have the two matrix, then we assume that T of n denotes the number of operations to multiply two matrices of size n by n. So see, the resulting matrix has dimension n by n, you know that. So once you are obtaining the entries, then you will have the n by n matrix. And means you have the n square elements. So you have the n square elements in the C. For obtaining only one entry, you need n number of multiplication. So obtaining n into n means n square entries, you need n cube operation. So generally, you can give that this is given as theta of n cube. So for obtaining the matrix product of size 2 by 2 matrix of size n by n using the brute force method, we require theta of n cube operations. Now our interest is what? We are interested to reduce the operations for multiplying the two matrix of size n by n. If you have the 2 by 2 matrix, so how many multiplication, element multiplication you need? 8 multiplications and 4 additions you need. What we need actually, we know that the multiplication takes more time as compared with the addition. So we need to minimize the number of multiplication here. The objective is to go for the less number of multiplication as we can. And this exactly is a thought of Strassen's matrix multiplication. So Strassen's, once you go for the Strassen's method, then Strassen has given the scheme, and using the Strassen's methodology, if you multiply the two matrix of size 2 by 2, so as compared to the 8, you will need only just 7 element multiplication for the 2 by 2 matrix. Now what we need to see that divide and conquer technique works also for the matrix multiplication, as we have seen divide and conquer technique works in the sorting methods. So we need to test it. So how you can apply the divide and conquer techniques for the matrix multiplication? So we have the two matrices of size n by n. We are going to test whether this divide and conquer technique can works for the matrix multiplication or not. So we are supposed to multiply the two matrix, and this is the matrix, say for example A of having n by n, and this is the matrix B of having dimension n by n. So you know that when n is equal to, if you have the n is equal to 2, then what we need? This is the small case. Means for matrix of size 2 by 2, if you want to multiply, you don't require to go for this method. Trivially, you will have the answer like we have seen previously for obtaining the product of the two matrix of size 2 by 2. So if you have the two matrix of size 2 by 2, then you can use this formula given in. So you can use this formula for multiplying the matrix of size 2 by 2. So this is the small case too. when the dimension, when n is equal to 2, then we can just use this formula instead of dividing the product. So we will have the answer. And you know that once you are using this formula, then for 2 by 2 matrix, then A11, B11, these are the element. So you are multiplying the element. So here you are multiplying the two elements. Here also two elements. A11, A12 is also element, B22 is also element, and you are going to multiply. And also you are going to add the two elements actually. So A11 multiplied by B11 is one element, and just this is also one element you are going to add. So when n is equal to 2, when n dimension n is equal to 2, then we believe that in case of matrix multiplication, the small case is true, and hence we don't require to divide the problem. If n is greater than 2, then actually we need to divide into the sub problems. So what we, if you have the n is more than 2, then we can divide the matrix of at the midpoint, means we will have the entries now n by 2 here, n by 2 by n by 2 matrix. You can just say that this is what, this is A11, just we say, and this is A12, and this is A21, and this is A22, where A21 is what, A21 is the matrix of size n by 2 n by 2. Okay, A11 is also a matrix of size n by 2 n by 2. A12 is instead of element, this is the matrix of size n by 2. So similarly, once you divide this also, then you will have the four matrices. So you will have the B11, here also you will have the B12. So this is the B12, and here this is B21, and this is B22. So what is the dimension of these matrix? B11, B12, B21, and B22, each of having the dimensions of n by 2, n by 2. So B11 is of having n by 2, n by 2. B12 is also n by 2, n by 2. B21 is also n by 2, n by 2, and B22 is also. So now you have divided into the half. Now you may have question that if n is not divisible by 2, then how you can divide? So first you need to consider that you have the dimension n, and you see that whether n can be expressed as the powers of 2 or not. If no, then you can add sufficient rows and columns of zeros. Okay, so adding the row columns of zeros and rows of zeros for making for for making the dimension which can be expressed as 2 raised power k. If dimensions can be expressed as the powers of 2, then every time you can divide. So once you have divided into the subproblems, then you will have here 4 matrix of size n by 2. Here also you have the 4 matrix. And if you multiply, if you want to multiply A and B, then what you need? You need to multiply this matrix with, just like we have seen that if you have the 2 by 2 matrix, then this A11 multiply by B11, like this. So instead of element here, actually instead of A11 is element, it is the matrix of size n by 2, n by 2. Instead of B11 as element, as it is the size of it is the matrix of size n by 2, n by 2. So how many matrix multiplication you require? So if you go for the recurrence equations for the divide and conquer, then you will see that let T of n is the number of operations required for the multiplying the two matrix of size n by n. Okay, so once you go for the divide and conquer, then we see that how you can obtain the recurrence relation for this. So how you can obtain the recurrence relation? So if n is equal to 2 by 2, if you have the, if just you have the 2 by 2 matrix, then you just require 8 multiplications, 4 and plus 4, 8 multiplication plus 4 addition. The total operations you require is what? 8 multiplication plus 4 addition means 12. So this is the operation you require. So when n is equal to 2, then you need this much operations. If n is equal to 2. If n is more than 2, then you need to divide. And once you divide, then you have to, you are going to, instead of multiplying the elements, you are going to multiply the matrix. So how many matrices you need to multiply? 8 matrices. So here you need to multiply 8 matrices. And what is the size? The size is n by 2. So we have assumed that T of n is the operations required for the multiplying 2 n by n matrix. Here similarly we are denoting that if you multiply the two matrix of size n by 2, then you need T n by 2 operations. And how many such multiplications you have? 8. So that's why 8 times this. Plus, once you have obtained, then you need to combine. And for combining, you know that how many additions you require? After the after the 8 matrix multiplications, you need to combine. So now this is not the element, this is the matrix of size n by 2 in that case. So you need to have 4 additions. And if you want to add the matrix of size n by 2, then how many additions you require? If you have the n by n matrix, 2n by n matrix, and you want to add the two matrices A and B, you want to add A plus B, each of having size n by n. So how many, what are the operations you require? How many entries are there? N square entry. So you just n square operations you require, n square additions you require. So that's why once you go for the addition of the matrix, then you have the 4 additions you require, and 4 for adding the one matrix, adding the two matrix, adding the matrix of size 2 n by 2, what you need? You need n by 2 square, and this is if n is greater than 2. If n is greater than 2, then you are obtaining this recurrence relation. So this is the recurrence relation appears for the divide and conquer techniques. Now you need to solve the recurrence relation for obtaining the bound of the matrix multiplication. So you can use the master method for solving this recurrence, because this recurrence is of type master method. Okay. So how you can use? So here T of n is A. If you compare with the master recurrence, then A is equal to here 8 A T n by B. So here A is equal to 8 and B is equal to 2 A T n by B plus, sorry, f of n. What is f of n here? F of n is this. Means you have the degree of the polynomial is what? 2. So f of n, degree of the polynomial of f of n, this is the f of n. So you can compute n raised power log BA, and when you compute n raised power log BA, then you see that log B is what? 2 and A is what? 8. Means 8 can be written as 2 raised power 3. Once you write like this, then you are having the answer NQ. So NQ, n raised power log B is NQ, and f of n is what? N squared. So n raised power log B is larger, polynomially larger than the f of n, and this is the case 1 of master theorem applies. Case first of master theorem. Applies. Okay. So according to the case first of master theorem, you come to know that n raised power log B is polynomially larger than f of n. So what is the bound? Bound is the larger one. So T of n is equal to theta of NQ. This is the answer. So once you solve the recurrence that appears with the help of divide and conquer techniques, if n is greater than 2, then you are obtaining the bound as theta of NQ. And see, whenever you have gone to the brute force method, then the time is remains same. The bound is remains same, theta of NQ. So there is no improvement. Even you are going to use the divide and conquer technique for the matrix multiplication of two. You want, if you want to multiply the two matrix of size n by n, then brute force method says the operations is theta of nq, and here with the help of the divide and conquer also you are getting the same bound. Means the number of operations required by the divide and conquer techniques for the multiplication of two matrices of size n by n is theta of nq, and hence there is no improvement even you are going to use the divide and conquer technique for the matrix multiplication. So what we can do? That's why Strassen has given the approach scheme for multiplying the matrix of size n by n different way as you are going to obtain the multiplication in the brute force method. Strassen thought that since we know that element multiplication requires more time as compared with the addition, so we need to minimize the number of multiplication, and at the same time addition or subtraction may be added. There is no issue because they take such operation, addition and subtraction takes less time as compared with the multiplication operation. Strassen has given the formula so that in the Stressen's formula for multiplying the two matrices of size 2 by 2, you just require only 7 multiplication and 18 addition and subtraction. So we have the 18 addition and subtractions. So see that in case of the Stressen's methodology, addition and subtractions increased, but the number of element multiplications decreased for the multiplying the two matrix of size 2 by 2. So here we have 7 multiplication only, and if you go for the brute force method, you need 8 matrix multiplications and 4 additions. So Strassens is able to reduce the number of multiplication by 1, just 1. And you may say that, okay, it is not the significant improvement. But see, when n is small, this is not the significant improvement, but n tends to infinite. If dimension is large, very large, if n tends to infinite, then with the help of the Stressen's methodology, if you multiply the matrix, it will take less time as compared with the brute force method. Means asymptotically, Stressen's method is fast as compared with the brute force method. Now the question is that how we can obtain the entries of C11 and your resulting, we are going to store the result in the C, and C is also having the uh, size 2 by 2, n is equal to 2 here, so you are having the size 2 by 2. So how you can obtain the entry with the help of the Stressen's methodology, where you require just only the 7 multiplication. So he has given some formula, so you just need to write down the formulas, and then you can first, he has given some formulas, and he is going to use these formula to obtain the entries of the C. So he has given the formulas like this. First you need to obtain, Strassen has obtained this formula, then using this formula he has obtained the entries for the C. So how he is going to obtain the entries for the C? This is the way you can obtain the entries. So see that how you can obtain the entry. And C11, if you go for the brute force method, then you know that C11 is what? If you go to the formula, then you see that C11 actually A11, B11, A12 and B21. So this is the formula. And using the Strassens, how you are going to obtain? Strassen says that C11 is equal to P plus S minus T plus V. So C11 is equal to P plus S, and P is what? P is this. P is this, and S is this. So P plus S. First you need to do like this: P plus S, then minus T plus V. So once you go for this kind of algebra, once you go finding the summations and difference, then you will get the entries just like the brute force method. If you have C12, if you want to obtain the entry for the C12, So what is the formula for the C12? This is the entry. And see, if you go for the Strassens, then C12, how it is going to compute C12? C112, if you simplify A11, B22, A11, B22, you can cancel. This is the minus and this is the plus. And what you are getting here? Just A11, A11, B12 plus A12, B22. And you can compare with this. So C11, C12 is what? A11, B12. So A11, B12, then plus A12, A12, B22. So A12, B. So this is the way you are going to obtain the entries. So once you go for this kind of algebra, then you will get exactly the same you have obtained using the brute force method for C11, C12, C21 and C22. This is the formula given by the Strassens, and he has also proved that we will not be able to reduce further number of multiplication. Means you will not be able to multiply with the two matrix of size 2 by 2 less than 7 number of multiplication. Stations require 7 multiplication. And how many additions and subtraction? 18. So how 7 multiplication comes? You can see exactly 1 multiplication you are using for every P, Q, R, S, T, U, V. Okay. And addition. So how many addition and subtraction? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15, 16, 17, and 18. So you have 18 additions and subtraction. So in addition and subtraction, total is what? 18, and number of multiplication is 7. You need to use the divide and conquer techniques, but instead of, when the problem becomes small, then instead of using the brute force method for multiplication, you just use the Strassens methodology. So you just use the formula given by the station. So this is the formula given by the stations. You can use this formula to obtain the entry when the size will become 2 by 2. So in this way, you are going to reduce the number of operations. So how the recurrence would look like? Now, when you go for the Strassens formulations, then if n is equal to 2, when the small case is 2, when you are going to use this formula, and according to this formula, what number of multiplication you require? 7 number of multiplication and 18 addition and subtraction. So total operations you have is 25. So this 25 is what? If n is equal to 2. When n is equal to 2, we require 25 operations. 7 multiplications, element multiplication, and 18 addition and subtraction. Total 25. But if n is more than 2, then you need to divide the problem into the subproblem, and each of having size n by 2, n by 2. So how many matrix multiplication you require here? You, according to the Strassens, you know that you need now, instead of 8, you need have 7 matrix multiplication of size n by 2. So here you have the n by 2. So you have the n by 2 size. How many matrices? 7 matrices. And how many addition and subtractions you require? So you require 18. Dimension is n by 2. So here you have the n by 2 whole square, and this is if n is greater than 2. So if n is greater than 2, then you have the recurrence like this. So you can use the master method. So how you can use the master method for this case? Here you can compare this with the master theorem, master recurrence, and you come to know that here, once you compare with the master recurrence, then a is equal to what here? A is equal to 7 and b is equal to 2. So a is equal to 7 and b is equal to 2, and here you have the f of n, and f of n you have 18 times n by 2 whole square. So here the degree of the polynomial is what? 2. So this is the f of n is of having degree 2. So what is the bound? You need to find out the value of n is power log ba. So once you go for the n is power log ba, then you will have b is what 2 and a is what 7. It comes 2.81. So n is power 2.81. So now this is 2.81. And what is the degree of f of n? F of n degree is what? 2. And here degree is 2.81. Means this is larger. N is power log ba is larger by the polynomial factor n raised power epsilon. And epsilon is what? Epsilon is equal to here. Here epsilon is actually equal to 0.81. So see the situation. So n raised power log ba is larger, polynomially larger. This is the polynomial of degree 0.81. It is the polynomially larger as compared with f of n. And we have seen the technicalities in the master theorem. When n raised power log ba is polynomially larger than f of n, then this is the case 1 of master theorem applies. So this is again case first applies. Case first of master theorem applies. And according to the case first of master theorem, what is the bound? So T of n is equal to theta of n is power log ba, and n is power log ba is what? N is power 2.81. So this is the bound you have obtained. So this is the bound you have obtained using the Strassen's method for multiplying the two matrices of size n by n. Now see the improvement. This algorithm has improvement over the brute force method and divide and conquer. Here you have used divide and conquer with Strassen's formula, not brute force method. So see that even this seems that okay, this for a small case, for small dimensions, it may not be significantly more. But once n tends to infinite, then the rate of growth of, if you compare the two functions nq and n is power 2.81, and nq is what? Nq is the operations for the brute force method, and here with the help of the Strassen's methodology, n is power 2.81. So if n tends to infinite, then nq is sufficiently large as compared with n is power 2 point. Rate of growth of nq is very large as compared with n is power 2.81, and hence asymptotically Strassen's method is fast. So when n is sufficiently large, you just go for the Strassen method for multiplying the two matrices of size n by n, and this is the actually improvement. So see that by using the concept of the Strassens, we are able to reduce the bound of the matrix multiplication from n is power q to n is power 2.81, and this is due to the Strassens methodology. So this is the this is the way you can multiply the two matrices of size n by n with the help of the different techniques. If you go for the brute force method, b require theta of nq time. If you go for the divide and conquer technique with multiplying using the two matrix, when you have the small case 2, then if you multiply according to the brute force method, then divide and conquer techniques with brute force method gives the again it gives the bond theta of nq. But whenever we go for the Strassen's method for multiplying the matrix, when it will become small, means it will become the size 2 by 2. And if you go for the Strassen's formula, then we are able to obtain the bond which is the theta of n is power 2.81. And this is the significant improvement over the nq. Okay, so this is the way people have thought how we can reduce the operations in the matrix multiplication. For small dimensions, it is not significant, but since we know that in the real life n can be very large, and once n tends to infinite, then 2 n is power 2.81, the rate of growth of n is power 2.81 is less as compared with n is power q, and hence asymptotically Strassen's method is faster as compared with the brute force or brute force with divide and conquer techniques. Okay, so this is the way you can multiply the matrix.